Hello, my name is Jo Myung-chol. I'm going to give a lecture on stable vegetable production techniques. I am in charge of developing pepper and tomato varieties for the Vegetable Research Division of the National Institute of Horticultural and Herbal Science, under Korea's Rural Development Administration. I think it will be challenging to detail all the techniques for stable vegetable production within the short time we have today. So today, I would like to touch briefly upon the following topics. First, what kind of crops should be grown? Second, the importance of selecting cultivars. Third, seedling growth techniques. Fourth, cultivation techniques, management of temperature, sunlight, water, fertilizers, and soil, and rain shelter techniques for growing peppers. Fifth, disease prevention and pest control. And sixth, post-harvest management. First, let me talk about what kind of crops we need to grow. When selecting crops, it is important to take into account the characteristics of the region where you are farming and the farm's conditions. The first thing to consider when choosing a crop is that it is important to choose one that is in high demand in the production area and is easy for farmers to grow. In Korea, vegetables used in making kimchi are important, so Koreans grow pepper, garlic, onion, radish, and Napa cabbage. In addition to these, more than 50 other kinds of vegetables are grown in Korea. It would be good to choose crops that will be in higher demand in the future, even if they are in low demand now. For fruit vegetables, tomatoes, watermelons, cucumbers, and strawberries will be good choices. And for leafy vegetables, cabbages and lettuce are good because consumer demand is likely to increase in the future. Third, it is recommended to select crops with potential markets, both in terms of exports and domestic demand. We can think of fruit vegetables such as bell peppers and tomatoes, for instance. Fourth, choose crops that can be managed after harvest. It is good to select and grow those that can be distributed after long storage through drying and processing after harvest. There are about 7,000 varieties of 15 to 20 crops in the world, and about 2,000 of them are known as vegetables. Major vegetables of native varieties include spider plant, African eggplant, nightshade, cowpea, amaranth, and Ethiopian kale. Among the native varieties, some tomato and cabbage varieties that we have grown have good nutritional value. When we looked into moringa, amaranth, and sweet potato leaves, we find in them a considerable amount of beta-carotene, vitamin E, and iron. Napa cabbage is the main ingredient in kimchi. Recently, a good variety of Napa cabbage has been developed. Napa cabbage is an important vegetable for making tasty kimchi. Next, this is a radish field. Radishes are also used in kimchi. Next, we'll look at peppers. This photo shows peppers cultivated in tunnels, those growing outdoors, and peppers hanging on plants. This picture is about the process of drying peppers after harvest. The next photo displays a garlic field. Garlic is an important vegetable in Korea as it is used for a variety of purposes. It is used in producing kimchi as well as for medicinal purposes, and it is consumed with meat. This picture shows how people harvest onions. Onions are used in kimchi and many other dishes. Next, let me discuss the importance of choosing appropriate varieties of the crop once you have chosen which crop to grow. After selecting what kind of crops you will grow, it is important to choose the right cultivars. I will briefly explain how to choose cultivars and then look at pepper varieties as examples to discuss the conditions that the crop's variety should meet, in consideration of each variety's characteristics, which in turn depend on breeding methods. As for tips on choosing cultivars, choose varieties that are commonly cultivated and ones that suit the purposes for cultivating that crop. Vegetables are not viable for continuous cropping, and they are often damaged by drought and excessive water. Therefore, you should choose cultivars that are resistant to disease and disaster in consideration of the weather conditions and soil properties of the region where they are to be grown, the environmental management conditions, sales channels, and consumer preferences. When you plant a new variety, it is a good idea not to plant them on the entire field right away. Instead, plant them on part of the field and see how it goes, and then plant gradually over the rest of the field. In addition, choose 2 to 3 varieties instead of just one. It is better to choose both early maturing and medium maturing varieties or varieties developed by a couple of different companies. Choose the varieties that are best suited to the region's climate conditions and cultivation facilities. And then, with a full understanding of the characteristics of the chosen varieties and how to manage them, grow and manage them in a way that is appropriate for their features. Each cultivar has different characteristics depending on how they are bred. First, let's talk about purebred varieties. Purebred varieties refer to those that are genetically pure, as they have been cultivated along with native varieties in one particular region over a long period of time. Their advantages include the fact that it is easier than with F1 hybrid varieties to develop new varieties from them. They are more likely to adapt to the region, and it is easier for farms to collect their seeds. But their disadvantages are that they are weaker than F1 hybrid varieties, and there is no heterosis effect from the crossbreeding of its parents. Most vegetable seeds that farmers grow in Korea are from F1 hybrid varieties. What are F1 hybrid varieties? These are varieties created through the crossbreeding of 2 different varieties, female and male parents, and they are of excellent heterosis, uniformity, strength, and quality. F1 hybrid seeds are costly because farmers have to purchase them every year, as it is not easy for farmers to collect their seeds each year, and it takes a long time to develop the varieties. When it comes to vegetables on the market in Korea, excluding lettuce, what is currently distributed is mostly F1 hybrid varieties. Let me explain the qualities that varieties should show, using peppers as an example. Generally, the varieties of peppers and dried chili peppers have superior fruit-bearing qualities. They should color and dry quickly and show strong growth into the later growth phase, and their fruits should be uniform in shape. Good pepper varieties are those that retain their quality when dried and produce a high quantity when ground into powder. The internodes should be short, making it easier to manage cultivation, and harvesting should be easy as the stem of the fruit is easily taken off from the stalk. Lastly, good varieties are resistant to diseases, pests, drought, and moisture damage. They should be less impacted physiologically by environmental conditions. Particularly in the initial planting period, good varieties for the climate conditions in Korea take root well, and they should robustly bear fruits which continuously become bigger during the low temperature periods and even during the hot summer when the temperatures are high. Their stalks should continue to grow strong into the later growth period and have no poor fruiting even when they are cultivated for a long time. Good varieties include those whose plants have shapes that are favorable for lighting, ventilation and dense planting, and fewer physiological disorders, such as Lyme deficiency, when grown inside a greenhouse. Given these traits and characteristics, it is advisable to grow the best ones for the cultivation conditions you have. Each country has different situations in terms of pepper varieties, so it is important to make an informed decision on varieties based on the detailed information you have on them. Even if you grow the same crop, productivity may vary greatly by variety. Weekly pepper production can differ as much as 2 times between 2 different varieties. Next, let me discuss the colors of peppers. When dried chili peppers are ground into powder, the intensity of the redness can vary by variety. Now, let's move on to diseases affecting peppers. We can see a considerable difference in disease resistance between resistant varieties and susceptible ones. Let's take Napa cabbage as an example. In the past, Korea had only autumn cabbage. But recently, a variety of Napa cabbages have been developed, such as those that can grow year-round, winter cabbage, autumn cabbage for kimchi, cabbage that grows on high lands in summer, and spring cabbage that is cultivated in spring. So we can basically cultivate Napa cabbage throughout the year by choosing from a wide range of varieties. Next, let's turn to techniques of raising seedlings. First, we need to think about why we are raising seedlings. Seedling culture refers to the entire process from sowing seeds to raising young seedlings for a certain period of time before the seedlings are transplanted to the main field. There is a saying in Korea that emphasizes the importance of growing seedlings. Raising good seedlings is half the battle in farming. In the past, before greenhouse nurseries were introduced, seedlings were raised in cold conditions. But later, when we started raising seedlings in greenhouse nurseries where temperatures could be raised, we found that farm production more than doubled. When skipping the process of raising seedlings and simply planting seeds in the field, you can tell that the number of plants drops considerably to a minimum of 20 to a maximum of 70. This means that successful culture of seedlings is the basics of vegetable farming. Let me discuss the advantages of raising seedlings. First, you can advance the harvest time and increase yield. Second, in such countries as Korea with 4 distinct seasons, it is possible to ensure stable production of crops like radish and Napa cabbage by preventing their flower stalks from growing in low temperatures in spring. Intensively growing young seedlings in a small area enables precision management, which can lead to lower production costs. In addition, you can increase farmland utilization by raising other crops on the land during the seedling culture period. Another advantage to raising seedlings is that they adapt well when they are transplanted onto the field. This picture shows the development of Korea's seedling culture techniques. At the initial development period, each farmer raised their own seedlings. But later, they started to collectively raise seedlings at the village level. And recently, specialized nurseries have been established that allow farmers to order seedlings and the nurseries grow and deliver them. The methods of seedling culture have also changed. In the past, farmers sowed seeds in the soil, But today, special techniques are used to grow seedlings, including hydroponics, plug seedling production, grafting, cutting, and other special seedling techniques. This shows a grafted seedling. Bed soils are important in seedling culture. The criteria for good bed soil include the following. First, its nutrients should be consistent to ensure uniform growth and development. Second, the physical and chemical properties should be appropriate to maintain the soil's properties sufficiently to raise seedlings without problems. Third, the acidity should be pH 6.0 to 6.5, which is a neutral soil. In addition, good bed soil should have no more than 0.5 to 1.2 millisiemens per centimeter in electrical conductivity. Fourth, good bed soil should contain sufficient fertilizer nutrients for growing and developing crops. Fifth, it should be free of pests and weed seeds. There will be a variety of bed soils available that fit the conditions in your country, from which you can choose as long as they are readily obtained and user-friendly. Korea imports a variety of ingredients from many countries to make bed soil. This picture shows the difference in growth and development of pepper seedlings by the type of bed soil. When we used bed soil with a high content of compost, the seedlings did not grow well. You can see the size of the crop vary by the type of bed soil or the mixture of components. For example, a bed soil that contains red clay or red clay mixed with compost. Let me explain briefly the characteristics of each type of bed soil of different ingredients. First, let's look at peat moss. Peat moss can be easily obtained at low prices, so it is the most common bed soil used for seedlings. It retains water well, usually 10 times its dry weight. In general, it is 1% nitrogen and is quite acidic at pH 3.8 to 4.5. It is considered relatively clean and light. Next is cocoa peat. This bed soil is made of fibers derived from coconut husks. It looks similar to peat moss on the surface and comes in light or dark brown. It is less contaminated. Unlike peat moss, it has a good water absorption ability. It absorbs water easily from the beginning of watering. So, this type of soil is excellent in terms of water retention and drainage. It is a good component for bed soil as its acidity, cation exchange capacity, and electrical conductivity remain within the appropriate ranges for raising seedlings. Next is perlite. You can make this soil by grinding the volcanogenic minerals of silicic acid compounds and then heating it up at high temperatures. It is light and aseptic as it was processed at high temperatures. It can hold 3 to 4 times its own weight in water and has low buffering and cation exchange capacities with acidity levels of pH 6.0 to 8.0. So, it does not contain inorganic nutrients and can be used primarily for increasing air permeability of a bed soil. Next, vermiculite. Vermiculite is made when you heat up and expand the minerals containing mica at high temperatures. It has a relatively high cation exchange capacity, so it can absorb many mineral elements. Its pH levels do not easily change because of its high buffering capacity, and it breaks down easily. It is aseptic because it is completely sterilized as a result of being processed at high heat. Horticultural vermiculite varies by particle size. Now allow me to present the management skills of various aspects during the seedling growth stage. First, let's talk about water management. In Korea, pepper seedlings are raised in winter. So, when you water them during low temperature periods, make sure to water them enough each time so that their roots are soaked. It is advisable to water the seedlings with water at 20 degrees Celsius. Manage the watering in a way that the surface of the topsoil in the nursery is slightly dry by evening. Second, let's talk about management of light. The light saturation point refers to the maximum light intensity that a plant can make use of. You should secure about 30 K lux, a sufficient amount of light for peppers. Insufficient light during seedling culture causes the first round of fruits to hang high. The number and quality of flowers decreases, so make sure they get enough light to avoid this. Let me now turn to temperature management. The optimal temperatures for growth and development of peppers are 25 degrees Celsius during the day and 20 degrees Celsius at night. In the evening, the temperature should be 18 degrees Celsius or above. If it is below the optimum temperatures, pepper seedling growth, development, and flowering will be delayed, slowing the development of new roots. Proper temperature management is important. The next part is about nutrition. The lack of nutrition during seedling culture results in poor growth and development, and can also slow down rooting when seedlings are transported onto the main field, thereby resulting in poor formation of flower buds. Use bed soils containing the right amount of fertilizer. If the soil needs more fertilizers from the middle of the seedling growth period, use urea and compound fertilizers. So far, I have explained the purposes of raising seedlings, their development process, bed soil types and characteristics, and the management skills required when growing seedlings. Taking peppers as an example, let me now explain cultivation techniques, specifically how to manage temperature, sunlight, water, fertilizers and soil, along with the rain-proof cultivation techniques. In this section, I will briefly discuss the following cultivation management techniques, using peppers as my example. First, how do we manage temperatures? Peppers originated in South America where it is hot, so this crop likes places with high temperatures. In the germination stage, when sprouts grow from sown seeds, temperatures during the day and at night should be maintained at 28 degrees Celsius to 30 degrees Celsius so that normal shoots appear within 2 or 3 days. After sprouting, the temperature should be lowered to 25 degrees Celsius to 27 degrees Celsius during the day, while nighttime temperatures should be maintained at 15 degrees Celsius and above, and the soil temperature at least 18 degrees Celsius. When planning to transplant seedlings onto the field in Korea, it's good to maintain temperatures at 22 degrees Celsius to 23 degrees Celsius, which is a little lower because the spring temperatures are low, and 14 degrees Celsius at night with soil temperature at around 15 degrees Celsius. Keep the seedlings in such conditions before transplanting them onto the field. When seedlings grow in the field after transplanting, a good temperature is between 25 degrees Celsius to 28 degrees Celsius during the day and 18 degrees Celsius to 22 degrees Celsius at night. But when cultivating peppers outdoors, we cannot control the temperature at will. It is not easy to adjust temperatures properly. Still, when you grow peppers or other crops, it is important to know the optimum temperatures for each and try to set the conditions to the right temperatures. This picture shows why we should manage the temperature between 15 and 30 degrees Celsius. To see pepper fruits, pollen germination is needed. The pollen tube needs to lengthen and be pollinated as well. If temperatures are below 15 degrees Celsius or above 30 degrees Celsius, the pollen tubes do not germinate or elongate well. This picture shows how important it is to maintain temperatures between 15 degrees Celsius and 30 degrees Celsius. Next, I will talk about managing sunlight during pepper farming. First of all plants need sunlight because they produce nutrients through photosynthesis. When it comes to light, there is a light saturation point, which is the maximum light intensity that plants can make use of, and also a light compensation point, which is the minimum light intensity that plants need. The light saturation point of peppers is about 30 K lux, which is lower than for cucumbers and watermelon. If the light intensity is too low or the length of day shortens, peppers will not grow normally. So basically, the more sunlight, the better. 70 to 80% of photosynthesis from sunlight takes place in the morning. Make sure your crops get a lot of sunshine in the morning. This picture explains photosynthesis. Plants take water, sunlight, and carbon dioxide from the air to make glucose. Sunlight is an important factor in the growth of crops. Make sure that peppers, radishes, and Napa cabbage get sufficient sunlight. There are several factors that affect photosynthesis. First, light intensity. If the sunlight is too strong, peppers cannot photosynthesize due to their lack of capacity to take in the strong sunlight. So, once peppers are exposed to a certain level of light intensity, that is, above 30 K lux, they cannot use it. On the other hand, if the light is too weak, plant bodies cannot feel it. Peppers need at least 2 K lux, which is the maximum light compensation point for peppers. The carbon dioxide concentration in the air is about 0.003%. The higher the concentration, up to 0.1%, the more photosynthesis occurs. This shows the importance of temperature in photosynthesis. If the temperature rises above 40 degrees Celsius, no matter how much sunlight and carbon dioxide there is, normal photosynthesis cannot take place. So, with the importance of temperature in mind, be sure to maintain the appropriate carbon dioxide concentration, sunlight exposure, and temperatures. This picture shows the results of an experiment where the number of flowers declined when the amount of sunlight was reduced too much. Third, let's look at managing water when growing peppers. Peppers are basically a shallow-rooted crop. They do not root deeply in the soil. For this reason, they are easily harmed even if it's only a little too dry or too wet. They tolerate dryness better than excess moisture. For example, too much water in the roots. So, if farmers manage the water properly, they can increase production and reduce physiological problems, such as sun scalding and lime deficiency. This is a picture of how the roots of a plant are impacted by well-drained soil and poorly drained soil. Since peppers hate to be underwater, it is important to drain the water away as soon as possible. Now let me discuss the fertilizers needed for peppers. We grow chili pepper seedlings in nurseries. and because they have a longer growing period in the main field after transplanting, they need more fertilizer than other crops. This table shows the amount of fertilizer needed per 10A, 300 pyong, which is the basic area unit for cultivating peppers, in Korea. This is not a definitive answer, as it varies from country to country and from farm to farm. The amount of fertilizer should be controlled through soil analysis of what is suitable for the region. In Korea, for example, the standard amounts of fertilizer are set according to whether crops are grown in open fields or facilities, and whether they are densely cultivated. Peppers have a long cultivation period, so when we prepare a field for the crop, we add fertilizers in addition to the top dressing. For the basal dressing, nitrogen and potassium should make up 50% of the total amount of fertilizer, and phosphoric acid, compost, and lime should be used all at once. The top dressing, which will be added after the basal dressing, should contain nitrogen and potassium in a 50-50 ratio. The dressing should be divided into 3 to 4 batches, with each batch spread over the field in 30-day intervals. This picture shows when fertilizer is given, how much is absorbed by the field, according to soil acidity level, or pH level. It shows that when the pH level is right, the fertilizer is efficiently absorbed. Take phosphoric acid as an example. In neutral soil, about pH 6.5, let's say we give 100 units of phosphoric acid. Then 100 plants can use it. But if the pH levels are 4.5 or 8.5, which means too low or too high, respectively, the plant bodies can only use half the amount of phosphoric acid fertilizer we give. So you should know the pH level of your fields accurately to know the soil acidity and raise the pH level if it is low or lower it if it is high to make the soil in your fields neutral. This table shows the pH levels of soil and corresponding fertilizer effectiveness. You can see that when we use 100 units of nitrogen, phosphoric acid, and potassium each in neutral soil of about pH 7.0, plant bodies can eat all 100 units. But in strongly acidic soil of pH 5.0, that is, when pH is low, plant bodies can only eat 43 units of nitrogen, 34 units of phosphoric acid, and 52 units of potassium. So this table demonstrates how important it is to adjust your field's pH to appropriate levels. Lastly, let me turn to adequate soil conditions for growing peppers. Peppers are a shallow-rooted crop whose roots do not grow deep in the soil. This means that they need a lot of air in the soil. This makes good ventilation and good drainage important, so that air circulates well in and out of your soil. When you grow peppers, keep in mind that neutral soil of pH 6.5 is good. This applies to other crops as well. For good farming, you should understand the characteristics of each crop, including the desirable soil pH level, drainage, and ventilation that crops need, and prepare the appropriate soil conditions for them. This greenhouse is a typical rain shelter greenhouse you can see in Korea. The advantages of rain shelter greenhouses are that they can prevent cold damage and damage from late frosts in springtime and help with maintenance of optimal air and soil temperatures. They allow farmers to accelerate crop growth and also begin the first harvest earlier than when farming on fields outside. Another advantage is that rain shelter greenhouses prevent frost damage in the later part of the growth period, enabling longer cultivation. But when you grow crops using rain-proof cultivation, be sure to maintain the best soil and nighttime temperatures in the planting phase. Ensure proper temperatures by opening the greenhouse doors during the day and closing them at night. And also, attention must be paid to managing temperatures and water so that physiological disorders caused by high temperatures, such as poor fruiting and lime deficiency, do not occur. In addition, it is important to maintain proper temperatures through ventilation and shading. When we cultivate peppers in a rain shelter greenhouse, we can see the number of peppers setting on a tree and the yield increase about 2 times. Moreover, an experiment showed that when we grow peppers using rain-proof cultivation techniques, crops are shielded in summer when it rains a lot in Korea, resulting in an 85% reduction in the incidence of anthracnose over non-rain-proof cultivation, while farms that use pesticide against the disease see the incident rate jump more than 85% compared to rain-proof cultivation. When it is not viable to build a large rain shelter greenhouse, even a partial rain shelter can dramatically drop the anthracnose incidence and increase production by 20 to 30% in Korea. This picture depicts the farming technique of shielding crops with covers, which was recently developed aside from rain-proof cultivation. This technique is to prevent spring frost by creating small tunnels and covering them with non-woven fabric instead of plastic. Covering can accelerate the planting time by about 7 to 10 days, helping to prevent low temperature damage during the initial phase of cultivation and increase production. Non-woven fabric covers can prevent low temperature damage. Non-woven fabric materials are used instead of plastic, so venting is not required, reducing labor accordingly. Recently, Korea has had hail more frequently in late spring due to unusual weather conditions. By covering tunnels with non-woven fabric, farmers can prevent hail damage and reduce the frequency with which they have to spray against aphids, mulberry thrips, and anthracnose. In addition, production increases with less pesticide and less labor, so this technique can contribute to increasing farm household income. This is the covering technique, using non-woven fabric. The covers prevent bugs from entering, preventing them from harming your crops. However, if insects are already inside before you cover, they are trapped inside, causing more serious damage to your crops. So, before covering, you must spray pesticide to kill all the pests. Let me now talk about preventing pests and pest control. In this chapter, I'm going to explain how diseases develop, the characteristics of soil-borne and airborne diseases, the reason that many diseases develop in vegetable crops, and the characteristics of disease occurrence by major pathogen. I will also talk about the causes of major disease by host and the characteristics of viral diseases that occur usually in tomatoes. Why do diseases occur in plants? Diseases cannot develop in plants if there are no pathogens or environmental conditions conducive to the development of a disease. If there are pathogens and suitable environmental conditions, but no plants, or if there are pathogens and plants, but not suitable environmental conditions, diseases do not occur either. No matter how conducive the environmental conditions are to the development of disease, if there are no pathogens, diseases do not occur. So, when pathogens exist and environmental conditions are suitable, plants will develop diseases. Let's look briefly at the characteristics of soil-borne diseases and airborne diseases. Soil-borne diseases start from underground, while airborne diseases develop in the plant body above the ground. Soil-borne diseases kill the entire plant or create systemic disease. Symptoms of airborne diseases are locally displayed, concentrated in a certain part of the plant, such as the leaves, fruit, or stems. It is hard to control soil-borne disease because their pathogens are inside the soil. Typical soil-borne diseases include bacterial wilt and Phytophthora blight. It is easier to control airborne diseases. But if you do not control them in the early stages, they can spread quickly, which means they demand your utmost attention. To get to the reasons that a lot of diseases affect vegetables, first of all, if you repeatedly grow the same crop in the same field, pathogens accumulate there. As a result, the incidence of disease increases. If you have a wide field, for instance, if you plant crops in one area of the field this year, move crops to a different area next year. This is a good way to prevent disease. Second, deterioration of the cultivating environment can be another reason. If soil acidity or soil pH levels are not appropriate for crops, disease may occur more frequently. As the organic compost required for improving soil is decreasing recently, there is a tendency for the fundamentals of the soil to deteriorate, thereby resulting in more diseases. Some diseases are caused by fungi. Most of these fungal diseases, such as rust, powdery mildew, and gray mold rot, have visible expressions. Next, let's look at diseases originating from bacteria. You can see some bacterial fluid secreting and a band forming around the lesion. And you can see wilting and bacterial canker. All these symptoms tell us we are dealing with a bacterial disease. Viral diseases rarely kill the plant, but instead their visual expressions are usually distorted or mosaic shapes on the leaves. In this slide, I will explain the major examples of soil-borne diseases, airborne diseases, and viral diseases by host, which means by type of plant, and cause of disease. The most typical soil-borne disease is wilt disease. This is caused by a bacterium known as Fusarium. When plant density is high, it occurs a lot. The hosts that pathogens invade include all vegetables and flowers, including cucumbers, watermelons, tomatoes, melons, strawberries, and orchids. If they develop this disease, their plant bodies wither and die or yellow, and their xylem turns brown and withers. Repeated cultivation in the same field for a long period of time causes this disease because pathogen density increases there. It also occurs frequently in soils with high EC, salinity, and acidity, when you fertilize the soil too much, or when you fertilize with compost, such as insufficiently rotten dog or pig manure. I will move on to Phytophthora blight. Phytophthora blight is a pathogen that comes from Phytophthora capsicii. The pathogen moves along in the water and is highly pathogenic and contagious. It is characterized by the fact that it spreads sideways along the water from a diseased plant. Phytophthora blight affects most crops, including peppers, watermelons, tomatoes, potatoes, pumpkins, cucumbers, melons, fruit trees, flowers, medicinal herbs, and aquaculture crops. Symptoms of Phytophthora blight include blight, root rot, stem rot, and fruit rot. crops eventually wither. When there is a lot of moisture, when the soil does not drain well, or when it rains a lot, this pathogen appears. When it rains for a long time, pathogens multiplying in the water spread rapidly along the movement of water. To prevent this, it is important to drain your soil well. Third, bacterial wilt. This is a soil-borne bacterial disease called Ralstonia. It occurs a lot in high temperatures and humidity, and during nutrient solution culture and aquaculture. It usually inflicts significant damage on solanaceous crops, such as chili peppers, tomatoes, and potatoes. Because the pathogen is a bacterium, it multiplies rapidly, drying up the crop as it is still green. That's why it's called green blight in Korea. To prevent this, grow the seedlings in healthy bed soils. And when a plant becomes a host of the disease, pull it out quickly and pour an appropriate inoculation pesticide into the removal site to prevent the disease from spreading to the next plant. Next, I will talk about the major airborne diseases. Gray mold rot is a typical example. This is a disease caused by botrytis. It affects almost all vegetables and flowers. It moves through the air, causing huge damage to crops grown in facilities. Its symptoms include the withering of flowers, rotting of fruit, spots, and soft rot. It occurs a lot in low temperatures and high humidity conditions. It is also common in onions, garlic, and fruit in storage after harvest. To control this disease, prevent large gaps in temperatures between day and night within the facility. Control air ventilation and humidity to ensure against low temperatures and high humidity. It is also important to remove diseased plants from the environment by burying them underground or burning them to get rid of pathogens. This is powdery mildew. Powdery mildew is also caused by a variety of pathogens, such as erisiph and sphaerotheca. Powdery mildew is an obligate parasite. This means that the pathogen can only grow on living plant bodies. So when the plant dies, the pathogen is no longer active. It spreads through the air, and white fungi form on the leaves like flour sprinkled on the flower petals. If there is not enough sunlight, or if there is a large temperature difference between day and night, or if ventilation is poor, this disease occurs, usually on leaves, and reduces the quality and quantity of produce. To control this disease, make sure there is no large temperature difference between day and night in the facility, and avoid a hot or dry environment. Moreover, it is good to bury or burn the tissues of the diseased plant. Next, let me explain anthracnose. Anthracnose is also caused by a variety of pathogens. Infectious agents in the diseased plant move in strong winds and heavy rains. This disease occurs usually during the rainy season in hot and humid conditions. As you can see in the picture, some symptoms include rot, and these symptoms are usually displayed on the stems and fruit of strawberries. A lump of so many spores that contain the pathogen are formed in the infected area. Planting resistant varieties is the best way to control it. However, the problem is that some crops still have no resistant variety. So, it is important to raise seedlings in isolation from pathogens using a pot or an isolation bench. Reduce pathogen density by ensuring good drainage when watering. Moreover, remove all diseased plants as soon as possible and burn or bury them. Now, let me discuss viral diseases that occur frequently in tomatoes. There are a variety of viruses, such as TYLCV, TLCV, and TSWV. CMV and TMV viruses are usually transmitted upon contact and during farming activities. CMV and TMV viruses move from one seed to another. TYLCV, TLCV, and TSWV are carried by insect vectors, such as tobacco whiteflies, mulberry thrips, and aphids. TYLCV stands for tomato yellow leaf curl virus. When infected, the tips of new leaves turn yellow and curl upwards. When tomatoes are infected with this virus in the early stages, production decreases 100%. This disease is usually transmitted by tobacco whiteflies. Tobacco whiteflies carry this virus to plants most of the time. When you disinfect your plants, these flies suck in the virus within 15 to 30 minutes and transmit it to other plants for the next 24 hours as they move. Because it takes about 15 minutes for the virus to spread, when a tobacco whitefly with the virus sticks its piercing mouthparts into a healthy plant body, it transmits the virus. The second virus that I want to talk about is TSWV, or tomato spotted wilt virus. This virus has become a very serious problem recently in Korea. If seedlings are infected with it, shoots and plant bodies easily die. When the body of a plant gets bigger after some multiplication of the virus, the disease creates circular spots on existing leaves or severely wrinkles new leaves. It makes typical circular spots on the fruit or deforms the shape. It is known to be transmitted by mulberry thrips. Let's look at the tomato mosaic virus. If infected, the leaves show yellow mosaic shapes and become deformed and thin. Depending on the variety, new leaves wither, or stems and fruit develop necrotic lesions. In addition, fruit fails to be well colored, with one side turning brown, resulting in low production. This disease is usually transmitted by farm equipment, agricultural activities, seeds, or aphids. This is CMV. Cucumber mosaic virus causes many small yellow spots and mottling of infected leaves and makes the leaves thin. Sometimes this virus causes the plants to shrink and deform. Usually this virus is carried by aphids, farm work, contact, and seeds. Once infection occurs, it is untreatable. So, before the viruses come, we need to know how they are transmitted. If aphids are virus carriers, we should stop the aphids. If mulberry thrips are culprits in transmitting the virus, it is important to prevent such pests. Cutting off infected plant bodies immediately is the best way to prevent the spread of the virus. Next, let me briefly explain some post-harvest management techniques. I am going to discuss crop loss that happens during storage and how to extend shelf life through a simple processing technique after harvest, and the importance of post-harvest management. It is reported that up to 40% of vegetables that are harvested are lost after harvest, and that much of the loss happens during the consumption process because we do not have sufficient post-harvest management skills or storage. We can reduce such losses sufficiently with simple processing, such as salting. But in many countries, there is a lot of vegetables lost due to a lack of post-harvest management. This is a best practice from Vietnam, where post-harvest management techniques have been improved. They developed a technique of manufacturing chili pepper sauce and tomato paste at low costs. With this technique, they have been able to harvest more vegetables, created consistent household incomes, and enabled year-round consumption of vegetables. This is an example of improving storage techniques by drying peppers or tomatoes, or making pastes or pickles out of them. Let me now talk about the importance of post-harvest management. First, it allows you to reduce crop loss, which is the number of vegetables dumped after harvest. Each country or crop loses 10 to 35% of its crop production in losses after harvest. Post-harvest losses of Korean horticultural crops are estimated to be worth about 4 trillion won. Therefore, post-harvest management, which aims to reduce crop loss, can be considered a second production activity. As for loss rates of horticultural crops by country, it is 5 to 25% in developed countries and 20 to 50% in developing countries, such as those in Southeast Asia and Africa. So the loss after harvest is quite a big problem. Looking into the statistics by product, 5 to 35% losses are reported with vegetables, 5 to 20% with fresh fruit and vegetables produced all year round, such as cucumbers, green peppers, and zucchini, 20 to 35% with long-term storage vegetables and leafy vegetables, such as Napa cabbage, and garlic, and 10 to 25% with fruits. Second, post-harvest management techniques can contribute to stability in supply and demand. When vegetable prices fluctuate severely due to imbalance of supply and demand, stored vegetables can contribute to managing the imbalance. If vegetables are harvested in large volumes and marketed, prices will plummet. Storing some of the vegetables can prevent sudden drops in price and maintain them at reasonable levels. In Korea, post-harvest management has prevented price spikes from limited production of Napa cabbages or price plunges from excessive production. Third, post-harvest management can enhance product value. Increase the value of your product or add value by packaging in small quantities or packaging washed vegetables. Fourth, post-harvest management can contribute to ensuring the safety of agricultural products. Consumers want good quality fruits and vegetables. They like produce that maintains its freshness, aroma, flavor, and color. What I mean is that you can protect those qualities in agricultural produce through post-harvest management. Several studies have shown that systematic post-harvest management can increase the prices of agricultural products 5 to 10-fold, or even up to 27-fold, if quality is maintained and post-harvest loss rates are minimized at each distribution stage. With this, I would like to wrap up my lecture on stable vegetable production. I have tried to explain a lot within the short time given to me, so I regret that I couldn't explain some parts in detail and give more information. If there's anything in my lecture you can't understand or would like to know more about, please email me, and I will address your questions. Thank you for listening.